In electrostatics, there are the two charges. One is a positive, another is a negative. So electric lines of force, they are also called as a field lines. So the electric lines of force, they originate from positive charge and terminate at the negative charge. That means start at positive charge and at the negative charge. In today's video, I am going to talk about properties of field lines or the properties of lines of force. Field lines and line of force are same. If it is a single, it is called line of force. If there are many, it is called as a lines of force. Lines of force start from positively charged body and travel up to the negatively charged body. And the lines of force start from every point of positive charged body. So every point, even though I have drawn only 3-4 lines, but there are the large number of lines, and from every point of the positively charged body, the lines of force are starting. In this property, we are going to talk about relationship between magnitude of charge and the lines of force. As the magnitude of charge increases, the number of lines of force also increases. For an example, consider 4 charges, 10 coulombs, 20 coulombs, 30 coulombs and 40 coulombs. In 20 coulombs of charge, the lines of force more compared to 10 coulombs. And in 30 coulombs of charge, the number of lines of force more than 20 coulombs. And in case of 40 coulombs of charge, the number of lines of force more compared to 30 coulombs, 20 coulombs and 10 coulombs. That means as the magnitude of charge increases, the number of lines of force also increases. From this, we can make one statement. The number of lines of force are proportional to magnitude of given charge. Lines of force, they are parallel. They start from positive charge and end at the negative charge, and all lines of force are parallel to each other. Now, how to get the direction of electric field? You can get the direction of electric field by drawing a tangent at a given point. There are so many points. So, if you draw the tangent at different points, you will get the direction of electric field at a given point. As the point is changing, the direction of electric field is also changing. Now suppose the lines of force are intersecting. If the lines of force are intersecting, then what is the conclusion? When the lines of force are intersecting, it will tell us, we get the information that if the lines of force are intersecting, then the electric field at a given point will have the two directions, which is not possible. Suppose we have the positive and negative charge, and this is the one line of force. Suppose another line of force is starting from the positive charge, and suppose they are intersecting at the point A. Then what is the problem? The problem is that the line of force intersecting at the point A will have the two direction. One is the like this, another is a like this. Let us call it as a AB. Another one is a AC. So the vector AB and vector AC are the two direction, which is not possible. At a given single point, the lines of force, the given line of force at a given point cannot have the two direction. It has only one direction. So there is no question of lines of force are intersecting. They are always parallel to each other. Another important property of lines of force that lines of force do not pass through the conductors. Example, they do not pass through the aluminum, they do not pass through the platinum, they do not pass through the gold or any other metal or conductors. So whichever the conductors, they do not allow the lines of force to pass through them. The next property, the angle between the surface and the lines of force is always 90 degrees. Suppose it is a equipotential surface and it is a positively charged body, and we know that from positively charged body the lines of force are coming out. So these are the lines of force are coming out, and according to this property of line of force, angle between line of force and the surface, angle between the line of force and the surface is 90 degree. That means suppose this is a surface and it is a line of force. So if you draw the tangent at the point of contact, and that angle is equals to 90 degree. So these are the lines of force and it is a surface. So angle between the surface and the line of force is equals to 90 degree. Lines of force can pass through insulators. For example, lines of force can pass through a plastic bag. Property 7. Spreading of lines of force depends upon electric field intensity at a given region. Now let us assume the lines of force are passing through the three regions: region A, region B and region C. Also assuming area of region A equals to area of region B equals to area of region C. Here we also observe that the number of lines crossing the region A more than compared to number of lines crossing the region B, as well as the number of lines of force crossing the region C less compared to number of lines of force crossing the region B. Now suppose we count the number of lines of force crossing the region A. 1, 2, 3, 4, 5, 7 lines. So here are the 7 lines are crossing the region A, and 3 lines crossing the region B, and 2 lines are crossing the region C. So in every region the number of lines crossing are different. What is the reason? The reason is electric field intensity in the region A more compared to electric field intensity in the region B more compared to electric field intensity in the region C. Thus, electric field intensity will decide the number of lines of force crossing a given region. From above discussion, let us summarize the points. Suppose the areas of all the three regions A, B, C are same. More the lines of force cross the region A and less lines of force cross through the region B, and more lines of force cross the region B compared to region C, implies intensity of electric field is more at region A and less at region B, and intensity of electric field at region B is more than region C. Conclusion is the number of lines of force crossing a region depends upon electric field intensity. We also notice that electric lines of force are crowded in a region where electric intensity is large. Electric lines of force are widely separated from each other in a region where electric intensity is small.